This is exercise 5C 3D trig. We did have a quick look at this a few lessons ago. So we've got this rectangular prism and this plane in red. It's like a sheet of paper that sort of starts from the top corner of this, let's say a box, down to that bottom corner. You've got to try and imagine that. Now, the first question is to write down the size of angle ABF. Looking down on that, that is a rectangular prism. What is the size of angle ABF? ABF, this is a rectangular prism, that is a right angle down on the base. Angle DBF, I would like to think of this as you've got a rectangular box, you're trying to fit this big piece of board or paper into it, and it doesn't quite fit. So that is like a sheet of cardboard. So these are right angles as well. That's a right angle, DBF. So is this one up here. It's a right angle. So is that, and so is that. So angle DBF is also 90 degrees as well. And in the next part, you have to find the angle that the diagonal plane DBFH. So that's just a plane. It's a flat plane, like a flat surface. Find the angle that this red cardboard or whatever it is makes with the base. So you're trying to find this angle like that. Yeah, so we're going to have to draw that. Okay, we want we need to find this angle. You don't have to come down along the middle. This length would be so we need this length, and we know this length. You want this angle in here. Okay, or this length, FH is the same as BD. Can you see that? And we know this length, that's 4. So is that. So you want this angle back there, or here, this angle at the front. They're the same. Or halfway through the page would be the same, halfway through that sheet. So that's 2. So's this. So's that. So AD is 2, so this is 2, that's 4. You can work out BD. Whatever, 34 minutes or something. So it's 27 degrees to the nearest minute. Degree, nearest degree. Okay? Sorry, so we didn't need Pythag there, but it's, you know, good to look at anyway. All right? Question 6. So we're going to talk through these. We've got a square prism. So girls, the base is a square. So it's not a cube. The base is a square, and there's your height. It's 4. So it's not a cube. It's not 666. It's 664. You might call this a rectangular prism. It depends which way you want to look at it. All right? But there's your square base, and there's your prism. Okay, we've got a plane ABC, so it's touching that top corner and then going down to 2 of those bottom corners. Just imagine, isn't the base, what shape is the base? It's a square, so isn't that whole length BD just the diagonal of the square? Tell me what sort of angle you've got here. Right angle. So that's what's going to help you with this, knowing that that base is a square. Okay? So they want the exact length of MD. MD. Well, girls, before you even start, you're probably thinking, but I know BD. So what I'm going to do, I'm going to draw a square. Start with this, girls. Yeah, MD. So girls, wait, for a start, that is a square. Tell me about the diagonals of a square. They're equal in length. Yeah, so girls, what we know is that, I'm just going to call this one E, because A is somewhere else in the diagram. I'm going to write the DE equals BC. DE equals BC because the diagonals of a square are equal. All right, and MD is a half of DE, or a half of BC. Okay, so what are you going to do, girls? What are you going to do? Off you go. So, girls, I want the distance MD exact length. So find the exact length. of MD. So we know that this is a square. We know that the diagonals of a square are equal in length. So I could just go 6, 6, can't I? Okay, so I can actually work out that DE squared, if I want, is 6 squared plus 6 squared. DE squared is 72. DE is the square root of 72. Can you simplify that? Third, what are your square numbers? 1, 4, 9, 16, 25. What's the next one? 2 squared, 3 squared, 4 squared, 5 squared. 6 squared is 36. Is that the one I want to choose? So that's 6 root 2. That's the exact length of DE. Are you okay with that? Because square root of 72 is the square root of 36 times the square root of 2. So therefore, DM is a half of 6 root 2, which is 6 root 2 over 2, which is 3 root 2. If they're going to ask you this in the exam, they're going to ask you for the exact length. Worked out what MD is. We now want the angle that the plane ABC, what angle does that, what angle does that make with the base? So we want the angle A. You tell me what ADM is, what that angle is, girls. Girls, that's straight up and down and that's flat. What's angle ADM? What sort of angle? Right. It's a right angle. So that's a right angle and they want angle AMD. Now you know the distance MD. So this is actually a right angle triangle with a right angle at D. So I'm going to draw that now. I'll do it in blue. So ADM, that is a right angle there. And there's AM. We just worked out the distance DM. So what we've actually got there is a right angle triangle like this. That's what we've got. ADM. You know that DM is 3 root 2 or, you don't know what, we do know that's 4. That's 6 and that's 6, so that's 4. And we just want this angle in here, which is theta. So you don't need to use Pythagoras' theorem. We don't need the distance AM. We want the angle AMD. So off you go. Sine, cos, or tan. This is a right angle. Opposite and adjacent. So we'll use tan, and you get 43 degrees to the nearest degree. You've got 3D trig problems where you've got planes and things like that sitting inside of prisms. The other 3D trigonometry type that you might get would be where you've got towers like this, or balloons or whatever, okay? And you're observing the balloon, for example, or the top of a tower from 2 different points, okay? So here, so what we've got, girls, P, Q, and C are all sitting on the ground, and B is directly above point C, okay? So, girls, if B is directly above point C, then you've got a right angle here. QCB, because BC goes straight up, CB goes straight up. You've got a right angle triangle here. You've got a right angle there. So I've got a person standing at P, okay? They're saying, now this one is quite tricky. They're saying a balloon B, so this balloon B is due north of observer P. Now when we do these sorts of problems, all the directions have to be looked at on the ground, all right? So see this point C, it's actually north of P, but they don't draw it straight up and down. They have to draw their, that north is on a 45-degree angle, otherwise you can't, see how that's drawn sort of sideways? If I was to draw that flat, C is actually north of P. I'm going to visualize it here in the room now. First, I'm going to draw it flat on a piece of paper in a minute, and I'm going to draw it oblique, which is on an angle for north. So I'm not going to be drawing, they don't draw north flat, straight up. They draw north on an angle because they're saying that, so a balloon, so the balloon is up in the air, but the balloon is directly above point C, okay? So a balloon B is due north of an observer P. So person P is standing there, they're looking in the direction of north and they see the balloon in the air. So the direction from P to C is north, but the balloon is directly above it. And that's still north. Because if I look down on the ground north, it's the same as looking up in the air north. I'm looking in north direction. Okay, now the angle of elevation, remember that's when you're looking from the horizontal up. This person P has to look up 62 degrees to see that balloon up there. Okay, now from another observer, so someone's standing there looking at the balloon up here, but someone's also standing at Q looking at the balloon here. So observer Q from another observer Q 100 meters from P. So there's P. 100 meters away is the person Q. The balloon is due west of that person. All right. So this from Q to C is west, but he's looking up. He's not. You can either look west straight on the ground, or you can put your head up and look at west as well. Okay. So this direction here is west, and the angle of elevation, this person has to look up 55 degrees. Okay. So they don't have to look up as far. That means they're further away. All right, and I'll explain why in a minute. So, the diagram they've given you. Okay, but I'm going to draw what's actually happening on the ground. They said that the balloon B is due north of person P. But when we do any directions or bearings, you have to do them on the ground. So what I've really got is that if B is north of P, then B is directly above C. C is north of P. So I'm going to draw a flat diagram. Here is C and here is P. That's what it's really like. Okay? Point C is north of P, but they draw it on an angle. Otherwise, you can't get the three-dimensional triangles going up. The reason they do that is so that they can draw these angle of elevation triangles. So this is an angle of elevation triangle, and so is this one. They're both right angle triangles, and you've got a triangle on the ground. So you've actually got three triangles. But I know that C is north of P. They've also told us that the balloon is west of Q. So if the balloon is west of Q, then C is also west of Q because C is directly below B. So C is west of Q. So Q has to be here. Do you get that? So look, C is north of P, and look, we know that B is west of Q, but B is directly above C, so C is west of Q. You know, if I've got north, south, east, west, west is that way. So that's actually what the bottom triangle looks like, the ground level triangle. So you've got to be able to draw a ground level triangle, because the others you can see, they're easy. But we need to draw the ground level triangle. Now that's got to be a right angle, like what Antonio said. All right? Because if that's north and this is west, north and west, I've got right angles all through here. So that's a right angle. So now on this base triangle, you've actually got a right angle. Okay? Now, some people really like to draw this base triangle separately. I know that PQ is 100 meters. Now, if I did draw the triangle like this is why they don't draw it flat. Watch. You know how I've got this angle of how, if I put B here, so B is not north of, the problem is that B is not north of C. It's just directly above it. So you can't draw it flat and then draw your angle of elevation triangles. They don't work. Girls, you can't. No, you cannot draw it. You can only draw each triangle flat. You can't draw the bottom triangle and the two angle of elevation triangles all in the one diagram if the bottom triangle is flat. It doesn't work. So what they do, whenever you're doing problems like this, you always draw north on an angle, and then that's what they've done here. Okay, so that north is always done on an angle. Otherwise, you can't draw the diagram. Okay, now, if that direction is north, watch. I know that C is north of P, right? See, if that's north, south, east, west, I know that C is, sorry. So there's my north direction. I've put north that way, watch. So I just, you know, move around like this. There's my north. I know that C is north of P, and I know that C is west of Q. There's my bottom triangle. That's my north line. The good thing about this now, because I've drawn it that way, I know that B lies directly above C in the air. I can now draw these other triangles. When I look up at the balloon from point B, this angle is 62 degrees. See how I can draw it now? Only if north is on an angle. Otherwise, I can't draw it. How am I going to draw that if north is not on an angle? How am I going to put B up there and draw a triangle here? You can't. It's flat. You get it? So you have to draw, for any artists in the room, north has to be on an angle of approximately 45 degrees in the drawing. Okay? And now the angle of elevation from Q to B is 55 degrees. So this is, remember, going straight up, and that's the ground. That's a right angle as well, and that's 55 degrees. And they told us that this is 100. Now we know that that's north, and this is going west. This is a right angle as well. So basically you've got 3 right angle triangles there on the ground. Now we can work out whatever we want. Okay, but we've got to understand the diagram first. So all directions have to be on the ground. The only things that you use for these red triangles are when you look up at an object in the air. But every other direction is on the ground. And distances pretty much are on the ground. Okay? That they've given us, we need an expression for PC. So I'm looking at that triangle with PC. I've got a right angle there. That's H, the height of the thing. So girls, I'm drawing PC flat. Okay? I'm drawing this whole triangle here. Look, PCB. I know the triangle goes up in the air, but I'm just drawing it separately. All right, do I know anything about this triangle? What do I know? Fantastic. And they've called this H. All right, so on the diagram, they've got H. So what can you do from here? You need an expression for PC, don't you? So what are we going to do? That's 62. So what are we going to use? They're not asking about that. They're asking about this. So, and you know that that's H. They gave you that the height of the balloon. You don't know what it is, but. So what are you going to do? Sine, cos, or tan? You don't know anything about PB. Yeah? Tan of 62 degrees is H over PC. So don't you just swap these? PC is H over tan 62. Now, do you know what cot is? What's cot's third letter? So 1 over tan 62 is cot. Because look, cot theta is 1 over tan theta. Do you remember that? The third letter. So that's just the same as H times cot 62. Because when tan 62 is on the denominator, so 1 over tan 62 is cot 62. 1 over tan theta is cot theta. So you write that as cot 62. Sorry, guys. It's a bit. 1 on tan is cot. You know the reciprocal ratios that we did last term? Now, they want a so we've just come up with an expression for PC. We want an expression for CQ. I want to draw this triangle now. CQB. So I'm drawing this other triangle, this one. It's a right angle. This is 55 degrees. That's still the height of my balloon. They want an expression for CQ. Same sort of thing. So PC is H cot 62. So instead of writing H divided by tan 62, you write it as cot. Move it. Because 1 on tan is cot. All right, what do you do now? Again, the same? Yeah, so don't you write tan of 55 degrees is what? H over CQ. So CQ is H over tan 55. And we know that something over tan is the same as writing cot. So CQ is H cot 55. Sorry, girls, I know this is very tricky. Triangles, 99.9% of the times are used to find measurements on the ground. Okay? So we use the angle of elevation triangle to find measurements on the ground. Sometimes we still don't know, especially if they're saying find the height of the balloon, find the height of the tower. You won't know what that H is. You just got to keep it as H. I'm going back to the original diagram. See this diagram on the bottom? We've just come up with an expression for PC and CQ. So I'm going to draw that. I can still draw it like this, but it's a right angle. I know that's 100. I've got PCQ. This is H cot 62. This is H cot 55 degrees. That's what I've got. So I'm coming back to this diagram. We just came up with an expression for PC and CQ. That's what I've got. What do you think I can do now? It's not trig. What else can you do with a right angle triangle? Okay. Now, ready? What squared plus what squared is what squared? Good. H cot 62 squared plus H cot 55 in brackets squared is 100 squared. Beautiful. Okay. Now I'm going to, isn't that H squared cot 62 squared plus H squared cot, sorry, you write cot 62 squared as cot squared 62 like that. Cot squared 55. That's how you write cot of 55 squared. And cot of 62 squared, you write it like that. Equals 100 squared. Now, how am I going to work out what H is? Isn't that in common? H squared is appearing twice. I want it to appear once. You factorize. Isn't H squared common? Cot squared 62 degrees plus cot squared 55 degrees. So I've got that squared plus that squared is that squared. You can't. What? No, it is. That's how you write cot 62 squared. That's how we write it. So, for example, if I want to write tan of 25, for example, tan of 25 squared is not written like that. It's written like this. That's how you write it. Okay, that's how you write squareds. Now, are you okay with why I factorized out the H squared? So how do you work out H squared? Isn't it H squared times that is that? So isn't it 100 squared over this? Now, your calculator does not have a cot button. It's got a tan button. So you know how they made us write it as cot? I prefer not to write it as cot. I'm going to write them back as tan. Actually, how do you work out cot squared 62? You can't work out cot 62 on your calculator. Cot 62 is 1 on tan 62. So to work that out, are we okay so far? That squared plus that squared is that squared. Square them all. Factorize out the H squared because you only want it appearing once. H squared times that is that. So H squared will be the 100 squared. Divide by that. The only thing we've got to do now is put it on our calculator. But there's no cot button. But there are tan buttons. What's the third letter of cot? It's T. So that's 1 over tan squared 62. And this is 1 over tan squared 55. Now you can do that on your calculator. You can enter it like that. So, but I don't, let's just see how we're going to do it on the calc. 1 over tan of 62 squared. You know what you could do? Oh, you can't even see the screen. Oh, here we go. I'm thinking go, where's your fraction button? 1 fraction, tan 62. Why don't you put brackets around the tan 62? Oh dear. I'm not good with this calculator. And square it. Can you see that? Do that. Can you see it or no? You can't see it. All right. Can you see that or no? what I've done on the calc. So I've got 1 over 10, because 1 squared is 1, isn't it? And then with that, I've got to add 1 over 10 of 55 squared. Because I don't think you can go 10 squared. Let me have a look. Sorry, girls, I don't think I was recording. So here we go. I'm doing 1 fraction bracket 10 of 62 close bracket squared, arrow across, plus 1 divided by, girls, 10 of 55 close bracket, just look at the screen, squared. You okay with that? Equals, and you get that. And then we go square root of the answer. Wait a sec. Something's wrong. Yes, it is. Oh, it was 100 divided by that. Sorry. I forgot to do 100 squared divided by that. So we go 1 fraction. Can you see the screen? I don't think you can press 10 squared. You can't. All right. So you've got to go 1 divided by bracket 10, 62, close bracket, squared. Sorry, I should use the fraction button. Plus 1 divided by 10, wait, bracket first. Where's delete? I can't find any buttons. Bracket 10, 55, close bracket, squared, equals, I would have done that together. Then that's your answer for those two things squared. 100 squared divided by that answer is 12,936. Square root of your answer is 113.74, or 114 to the nearest meter. One step, but that's how it has to look on your calculator to get h squared, 12,936.518. So enter it to look like that, and then h is the square root, okay? So that's how you want it to look on your screen, like this. It's much easier because they gave you got your angle of elevation, you've got your angle of elevation, you've got a right angle down here, but they gave you the height. So this is actually easier, this type of problem. So there's a tower, okay? They gave you the height. Don't write anything yet. They gave you the height. They gave you looking at the tower from point P, looking to the top of the tower. You've got to look up 15 degrees. Looking at the tower from point Q, you've got to look up 18 degrees. But because they gave you the height of the tower, this one is much, much easier. What they do is they ask you for an expression for BP. Noticing they're asking you for lengths on the ground. And BP is easy this time because you're just going to use tan and you know what the height of the tower is. And then they want an expression for BQ, okay? And then they want you to work out the distance between the two landmarks. So let's do this one. Actually, we will do this one. It's a bit different. So we've got two landmarks, P and Q. You're looking at the top of a tower again. I haven't even read it correctly yet. So P and Q are on the ground. We're looking at the top of a tower, just like that balloon question. But this time they've given us the height of the tower. They told us that P is due south of the tower. So that means if P is due south of the tower, then P is due south of B, because T is directly above B. So that means that north is this way. If P is south, that's north. And they've told us that Q is east of the tower. So if this is along east and that's south, girls, if that's east and that's south, that angle on the ground is a right angle. So I can draw that flat in a minute if I want. Okay, girls, this is what we've got. They've told me that P is due south of the tower. Top of the tower is there, but there's the base of the tower. So if this is south, then that's north. That's a north line. P, B. They told us that the tower is east of Q. So if that's east, that's west. East-west line. That's a right angle. But notice again, they've drawn north on an angle. Otherwise, you can't do these angle of elevation triangles going up. That's why they draw it on an angle. Okay, now, you've also got these other triangles. So you've got the angle of elevation triangles as well. So you've always got a ground level diagram, triangle, and you've got your angle of elevation triangle. So I like to draw them all separately. So I'm doing my angle of elevation triangles. P, B, T. 15 degrees, that's a right angle. And let's draw this other triangle here. B, T, Q, 18 degrees. We also know that the height of the tower is 30 meters. Now, in part A of this question, they're asking you for the length of PB and BQ. How are you going to do it? PB. We want the lengths of PB and BQ. How do you do it? Go. Yeah. 10 of 15 is 13 on PB. So PB is 30 on 10, 15. You could work it out if you want, or you can just leave it. Okay, I'm just going to leave it. Do the same thing here. 10 of 18 degrees is 30 over BQ. So BQ is 30 over 10 of 18. So we're going to do the same thing as we did before. But we've got our ground level diagram. So I know what PB is and I know what BQ is, and I can actually work them out. But I'm not going to, because I know that you can put them on your calculator, but you're going to have to keep lots of decimal places. Now, I have to find the length of PQ. Isn't this a right angle on the ground? Okay, so one sec. PBQ. I know what that is. I know what that is. That's a right angle. So how can I set it up? What squared plus what squared? You want PQ squared is PB squared plus BQ squared, ladies? PQ squared is, girls, you've got to square these, and it's pretty easy to enter onto your calculator. Ladies, girls. So PQ squared is PB squared plus BQ squared. Same thing, Pythagoras' theorem. You just substitute in. I'm going to write the squares straight away. Isn't that easy to enter on your calculator? Right? We get an answer for that, and PQ will be the square root of your of whatever it was. Okay? Okay, so PQ will be the square root of 21,000, which is 145.12, so it's 145 meters to the nearest meter.